Hi everyone, and welcome to Diversity of Life with me, Massey. Back from a fantastic time at Furry Equinox, but the con train just keeps going. I will be at Furry Weekend Atlanta next week, and in honor of the theme, Well, wait, no. As I was saying, in honor of FWA's theme, Galactic Gunslingers, I'm going to be touching on extraterrestrial life. The study of extraterrestrial life is actually a very broad field. In the widest terms, this is formally known as astrobiology. At its core, astrobiology is the study of the origins of life, evolution, and life's future. This is because in order to understand life's potential elsewhere, and in particular finding places that it could occur, understanding our origins is the quickest route. After all, the universe is a very, very large place. As such, astrobiology kind of involves every kind of science. The chemistry that makes us up, the physics that gives our inhabitable planet its properties, and of course the biology of understanding the climatic variables needed to sustain life-giving compounds, and what the extremophile biodiversity is on our own planet. All of this goes into astrobiology. If we want to specifically talk about the search for life on other planets, and the possibility for a given planet to harbor life, as well as what that life would look like, this is referred to as exobiology. This field of study condenses astrobiology into finding hypothetical life-supporting planets and evaluating them. The study of astrobiology and exobiology has been ever present in human society, but it only really recently came about in a formal and scientific sense. This came about in 1953 when Chicago scientists Stanley Miller and Harold Urey artificially created the building blocks of life in the lab, amino acids. They did this by mimicking the planet's atmospheric conditions of early Earth, and created 20 amino acids that could be used to make nucleic acids like DNA and proteins. This research initiated an exobiology program at NASA in 1959 and further gave intrigue to the hypothesis that after the Big Bang, asteroids became conduits for amino acids and spread these life-forming compounds throughout the universe. Since then, we have been on a fervent hunt for planets that can sustain life. Each year, we're discovering new and amazing worlds that could be another Earth, that can sustain and breed its own form of life. Since our search began, over 3,000 planets have been discovered that could support life. We are quite a ways off from the confirmed 50 million inhabited systems of the Star Wars universe, but we're certainly getting closer and closer each day. The main way we evaluate whether a planet can sustain life is if it falls in the habitable zone. This is the area around a star that can support liquid water. Too close to the star and the surface of the planet becomes too hot and the water evaporates. But too far and the surface is too cold and the water freezes. One such planet that was discovered in 2016 is Proxima b. This planet is in the habitable zone around the star Proxima Centauri, and it may be the closest exoplanet to us at 4 light years away. Habitable is a bit stretching it though. The surface temperature is estimated to be at negative 39 degrees Celsius most of the time, and with wind pressures 2,000 times of that on Earth, a vacation to this planet probably leaves something to be desired. But while not habitable for us, it may be for something else. Extremophiles are organisms on Earth that survive in some of the most extreme conditions on the planet. These are mostly microorganisms, but they're things like tube worms that live in undersea vents that reach up to 122 degrees Celsius, or ice bugs that live at 0 degrees Celsius or 34 degrees Fahrenheit. And we can't forget the tardigrades that can survive for 120 years without food or water and can live for months in the vacuum of space. Surely, if things like this exist on our planet, something could have started elsewhere under these conditions. Or maybe we could make it. Perhaps we could ship some of our extremophiles off to terraform these exoplanets. Surprisingly, we may be doing this without even intending to. Panspermia is the hypothesis that life exists in the universe through debris shaved off from life-containing planets. Over the history of our planet, it's been bombarded with asteroids. So the idea of a chunk of our planet with life, or at the very least organic compounds, is not that far-fetched. There is even a theory that the radiation pressure from the sun is enough to transport small particulates and organic matter off the planet. Accidental panspermia may already have happened even. Despite space exploration agencies' policies about decontaminating space vehicles and exploration drones before starting their mission to avoid contaminating other planets with our life forms, some bacteria have been found to be resistant to decontamination procedures. This means that our space probes could be little spaceships for colonizing other planets. Directed panspermia, or the act of facilitating the dispersion of organic life across the universe, has been an idea proposed by numerous notable scientists. Francis Crick, a Nobel Prize winner and a scientist who had the hand in discovering the shape of DNA, fantasized that early RNA was a product of other organisms' goal of terraforming our planet. And perhaps our goal should be the same with DNA. Professor Mothner of Virginia Commonwealth University wrote a fascinating paper about our place and drive in the universe. In summary, he states that it is the goal of biological life on the planet to reproduce and spread. Would it not be humans' ultimate cosmic purpose to secure the future of life in the universe? He proposes that this can be accomplished via direct panspermia from Earth to other worlds. He states that we have the technology and the means to start this, but what are the ethical repercussions? Should we become the engineers seen in the Aliens franchise? I'll put his full article in the description down below, so be sure to check it out. The universe is a vast and incredible place. Perhaps it's inevitable that we will find extraterrestrial life, or it finds us. But regardless of our place in all of this, I know my place, and it's at FWA next weekend. Hope to see you all there. As always, I want to hear from you. What do you think about panspermia? Should we terraform other planets? Do you think life already exists in some of the exoplanets we've found? Let me know in the comments below. Thanks so much for watching. If you liked what you heard here, please hit the like button. If you want to see more, subscribe. If you want to see more of my furry antics, follow me on Twitter. Be careful on your travels across the galaxy to FWA next weekend, furry friends. You never know what or who you might encounter. See you later!